This next one is a percent yield. I don't have extra notes yet. Maybe I'll develop them along the way. Stoichiometry in general is that 5-step process. At least that's how I'm following it because I know how to do my mole ratios. But I need maybe some extra notes for percent yield, which I may add to this. The reaction between 15.8 grams of NH3 and excess oxygen gas produces 21.8 grams of NO, nitrogen monoxide gas, and some water. Determine the percent yield. First thing I'm going to do is write and balance the equation. NH3 reacts with oxygen, produces NO plus H2O. Balance in this one, we're going to find out. I'm just going to cut to the chase here. It's a 4, 5, 4, 6. So first thing to do is I'm going to write and balance that equation. Check. Okay, so when I start to read about these, they're asking me if I start with 15.8 grams of NH3, excess oxygen, I don't care about that, but it produces 21.8 grams. I've got two numbers, so I've got to kind of figure out which are the important numbers. This is a produces, so that's a product. And so that's what they're going to be asking me about, is the nitrogen monoxide gas. Since NH3 is a reactant, that's what we're going to start with. Since NO is a product, what they're telling me, since it produces it, this is going to be my actual. So I won't need that number till later. So it's in grams. The steps would tell me to box around what I was given and what I want. I think I already did that. And the next thing I have to do is convert to moles if it's in grams. So when I look at 15.8 grams of NH3, how do I convert to moles? 1 mole of NH3 is, an N is 14, 3 H's is 3, which is 17 grams. So when I divide that out, I'm going to get 0.93 moles. So this is going to be 0.93 moles. This is excess. It's not important. We start with 0. We start with 0. The important thing I'm going to be needing to figure out is how much nitrogen monoxide, or NO, can I get? If I start with this, how much of this should I theoretically get? Well, check the mole ratio. If 4 makes 4, well then 0.93 should make, I could do the math over here, 0.93 times 4 over 4, but that's simply times 1.93 moles. That's nitrogen monoxide. Check my convert to moles. Set up the BCA. Now I just got to convert back to grams. 0.93 moles. This stuff is big N, big O. How much does 1 mole of NO weigh? That's 14 plus 16, which is 30 grams. Those numbers come from the periodic table. 0.93 times 30 equals 27.9 grams of NO. That's how much we're supposed to theoretically get. So probably somewhere on this percent yield, I should write something about the formula, is that it's going to be actual divided by theoretical times 100%, or times 100, which will equal a percent. So that might be something else I'd put there for percent yield. Another thing is I might write myself a note about how to determine between which number is the important one to start with and which isn't. And maybe I'd write something about identifying that one number is a reactant. That's what we start with. The other number is a product. So the product will be the actual yield. Not done with this one yet, because they ask about yield. So now I take what they said I got, the actual 21.8 grams, divided by what I was theoretically supposed to get, 27.9 grams. That ratio times 100 will equal 78% yield.